Okay, hello everyone, and thanks for joining us for another session at Persian Power BI user group. I'm super happy today because I have two great people here with me. So, Omid with us as a new admin of this user group. Omid, how are you, mate, today?
I am fine. I want to say hello to everybody, and I'm really eager today that we have Melissa with us, who always presents something great. I can't wait to hear about it.
That's great. Yeah, for a long time we are waiting for today, Melissa, and we are super happy to have you here and looking forward to learn more from you. You're always bringing some new tricks and new way to doing things. So that's great. So how are you today, Melissa?
I'm good. Thank you so much for having me. So I'm really looking forward to today and getting a chance to present on a new topic, at least this one, uh, talking about equality in Power Query.
That's a good one. Equal or close enough. Rethinking equality. That's one of those topic which I don't know the more detail about the details, more information about the details of this presentation, but it should be something great because I have some ideas in my head, and I'm sure you will support them and cover them during this presentation. For those people who don't know Melissa, Melissa is the Microsoft MVP and talking about everything Power Query and Power BI and covering many of those complicated areas with a great solution for those things. So I'm a big fan.
Awesome.
That's great. So I shared your screen. So over to you.
Perfect. I'll get started. So, hi everyone. It is absolutely great to have you here. And today we're going to talk about something that should be really simple, comparing text values. So, you know, the moment when you do a quick sanity check and you look at your data side by side and think, these are clearly the same, right? But Power Query says, no, they're not. And you're left wondering why that is. So the first time it happened to me, I stared at the screen and thought, what is going on? Of course, it turned out to be something trivial. One of the values had a trailing space, something I couldn't see. But we all know that the devil is in the detail. So next time it could be inconsistent letter casing, a tab, or who knows. And that's why we are going to redefine what equality means. First, we're going to look at how Power Query compares values and why, from our perspective as a user, that can sometimes fail. Then we'll explore building comparers and the two different types of jobs that they fulfill. And finally, we'll take a look at building a custom comparer, teaching Power Query our rules for comparing text values. So next time Power Query tells you, nope, those values aren't the same, you will know exactly why that is, but more importantly, how to take back control. So my name is Melissa, and I love sharing what I've learned and discovered about Power Query, and especially the M language. So for nearly a decade, I've been active in the community, answering questions, sharing solutions, and that over time grew in creating other content as well. But my goal is simple, to make data prep easier, and who knows, even just a little more fun. I'm honored to be a Microsoft community super user, Microsoft MVP, and of course co-author of the definitive guide to Power Query M. Some of you may know me from LinkedIn, or perhaps from code samples I share on GitHub. On the screen, there are 3 QR codes. One takes to the book, if you want to check that out. One to connect with me on LinkedIn. And the last one to my GitHub gist, where I share samples. During this presentation, I will stop for questions, and feel free to ask any on-topic questions at that time. For any off-topic questions you might have, please save those till after the presentation. Awesome. All right, so let's head over to the Power Query editor. Let me see if I can find it. There we go. All right. So the first thing we need to understand is how Power Query compares text values by default. And you may already suspect it's a lot stricter than you might be used to from Excel or even DAX. Now, there are two simple basic operators to perform equality checks. Those are the equality operator, that's just the equal sign. And you can create an expression that looks something like this, right? X equals Y, and that will return true if the values are equal, else it will return false. Pretty simple. Then, of course, we can also do the inequality operator. That looks like this. Now, a critical rule that is that if one of the two operands is not of the same type, like when comparing a number to a text value, for example, they are not considered to be equal. So here we're asking the question, is the numerical one unequal to the text equivalent one? And of course, the answer is true. Pretty simple. One thing to keep in mind, which is also different from behavior in Excel or DAX, is that there is no such thing as implicit value conversion in the M language. If you try something like multiplying the text value by 1 to convert it into a number, M will just throw an error. Other than that, of course, you can use functions, standard library functions, to test for equality. For example, value equals. Again, the same thing, a numerical one compared to a text one, and that returns a false. The key point that I'm trying to make here is that types matter in the M language. And today we're going to focus on text values. Now, by default, when M compares text values, it does so on a character-by-character basis, and it looks at the underlying Unicode value for each of the characters. That sounds a bit abstract, but let's take a look at what that actually means. So here we go. So every character that you see on your screen, letters, digits, punctuation marks, and even characters that you can't see, like tabs and spaces, for example, they all have a unique number to identify them, a code point value. Right, among the text functions, there are two that can help us explore that. Now, the first is a character to number, which takes a single character and returns its Unicode number, which is similar to Excel's code function or DAX Unicode function. So here we're providing it the capital letter A, and it returns the number 65. And we can do the opposite as well with the function character from number. That takes a number and returns the corresponding character, similar to Excel's char or DAX's unichar function. So here we're giving it the number 97, and that returns a lowercase letter a. So when comparing the uppercase letter A with a lowercase letter a, it's literally comparing the numbers 65 with 97. We all know the outcome of that. All right, so M compares one character at a time. So what if you want to see the code point sequence for an entire cell content? Well, there's a pattern you can use for that. And I've got it here, so let's take a look. So this takes a text value called string, and if that is a null with the coalesce operator, provides an empty text string instead. This is just a method to avoid errors. Then it transforms that sequence of characters or that text into a list with individual characters that can be processed one at a time. We're invoking the character to number function on each of those values in that list, and then of course, turning that number back into a string before combining them. So basically, this is an X-ray, revealing the underlying code point sequence for the thing that M is actually looking at when comparing values. This sometimes makes it easier to spot differences. So let's take a look, and I'll invoke this function on a very simple query that I've got prepared right here. So let me cut that back. So I love using that mini table icon in the top left corner. So I will click that, invoke a custom function. I'm not too bothered by giving that column a proper name, but I'm going to invoke the function that I just showed you, and we're going to invoke that on the value1 column. So I'm switching to column and selecting the value1 column from the available options. So there we go. So here is the sequence, the code sequence that M is looking at when it sees these values as part of a comparison. Now, I don't know if you've already noticed, but although visually the values for the top 3 rows look like they have the same length, if we count the number of code points that they return, that doesn't seem to be the case. So row 1 has 5 code points, row 2 6, and row 3 7. Now remember, comparing text is not just about letter casing. Everything counts. Whitespace, tabs, line breaks, digits, punctuation marks, you name it, they all have a unique Unicode value too. Of course, there are times where this default strict matching method is precisely what you need, and that's perfect. But especially in cases when you're working with unstructured data sources, that won't always be the case. Sometimes it doesn't matter how a word is written in lowercase or in uppercase letters, it all describes the same thing. And the gap between what we want the same to mean and what the M engine thinks that the same means, right? That's where comparisons come in. So now that we know that M and Power Query is very strict, case sensitive, and Unicode based, let's see how we can bend the rules without writing any custom M code at all. Because M comes equipped with 3 comparers. And you can think of those as rulebooks that you can hand to a function. And the 3 comparers are compare ordinal ignore case, and compare from culture. And when invoked, each of these comparers returns a number. So -1 if the first value is less than the second value, a 0 when they're considered to be equal, and 1 if the first value is greater than the second one. Comparers are designed to perform 2 related jobs. That's equality testing on one hand, and sorting and ordering on the other hand. So let's take a look at sorting and ordering, right? Because then it's really helpful that these functions return a number to determine the relative position of 2 values that are being compared. So here I've got a sample query, and I'll open this up so we can actually look. I've got a list prepared here with a couple of letters. Now we already know how this is going to end up. At least I hope by now you have some inkling as to what's going to happen. We can use a function list.sort and invoke a comparer. So here we're just applying the default rules. We're saying compare them ordinally. So here we go. The uppercase letters come before the lowercase. Makes perfect sense. But because the default rules apply, we can even order them ascending, because that will yield the same result. So knowing the underlying code point value is used, right, that ordering them ascending yields the same result, because uppercase letters come before lowercase ones because their Unicode number is lower. So a capital letter A will always be sorted before a lowercase letter. Like we saw earlier, it was just comparing 65 with 97. And we can actually make that visible. So we can make visible what this is returning using a function value.compare. So let's take a look. Here we go. Again, think of the capital letter A as 65 and the lower letter A as 97, and it's returning -1. So it's telling us the capital letter A is lower or smaller than the lowercase letter. All right. Time to make it a little bit more practical, right? And take a look at a very common requirement, and that's grouping values. So here's our simplified example. And let's imagine that we have a table that looks like this, and we want to count the occurrence of each value. Sounds really simple. And there's actually a pretty powerful function that can help us out with that. Now, that function is called group by, and you can access it from the ribbon. So it's here. I'll select that, and this dialog box shows up. Here we have the key columns. Now, I only have one column, and that is also the column that I want to group on. That's fruit. And all I want to do is count the rows to make sure that I know how many times each fruit appears within this table. I'll press OK. And you may have already expected that apple and apple here, they don't end up being placed in the same group because of that letter casing. But that's where we can take advantage of the fourth parameter of table.group and pass it a comparer. So we'll give it a modified rulebook to apply, in this case, ignoring casing. So here we go. Inside the formula bar, I'll just place my cursor just before the closing bracket, enter a comma there. Group kind, I'm not going to do anything there, so I'm just going to pass a null. And for my comparer, I will now just call one of the default rulebooks for ignoring case. So ignore case. There we go. I'll hit that tick, and now things look up, right? This was the outcome that we were expecting. All of the apples landed in the same bucket, and I now have 3 of them. Perfect. But more importantly, we didn't have to manipulate our data or write custom M code to achieve this outcome. So even before writing custom code, building comparers let us change how groups are formed, how sorting behaves, and how equality is determined. So up to this point, we've talked about ordering, functions that care about less than, equal to, or greater than, but often we just want a simple yes or no. Are these 2 values equal to one another? And that's where an equation criteria comes in. So that's the second job that comparers fulfill. So like I said, some functions really don't care about ordering at all. They care about equality, and they have a parameter which is referred to as the equation criteria, and that returns a logical result, so simply a true or a false. Let's take a look at basic comparers. And this is the table that I showed you earlier, a very simplified example. And I'm just going to invoke one of the default comparers to see how that helps us when we're looking at equality testing. All right, so here we go. I'll use that mini table icon again, but this time I will just add a custom column. There it is. So add a custom column. Again, not to bother with the name, I'm going to call the comparer that we used earlier to ignore casing. So here we go, ignore case. Open that up, and it just wants 2 values, two values to compare. So from the available columns, I can double-click them to bring them into the dialog box here. So I'll double-click this one, enter a comma, and I'll double-click the second one, close that off. It's telling me I've done a good job, so I'll hit OK, and this is returned. So we have a 0. That means that the first one is deemed to be equal when we're ignoring case. Returns a couple of 1s and even an error and a -1 somewhere. Now, I must say that this result is pretty terrible when testing for equality. You'll probably find the need to translate those zeros into trues and everything else into false. But here's the good news. You don't have to do that because Power Query has a function that can help us with that. And here's what that looks like. I'm going to do the same thing, add a custom column so we can see that in action. So add a custom column. Here we go. And that function is called comparer equals. So here we go. Highlight that. And it's telling us, give me a comparer. So we can actually pick one of the built-in library functions to help us out. In this case, we'll use the same one. We're going to ignore case. So ignore case, comma, and then bring in the values to compare. So our X and our Y. I will choose them from the available options here again. Close that off and hit OK. So this function takes a comparer, takes the two values, and then instead of returning a number, it simply returns true or false. Now that is simply lovely. Okay, so time to do a quick recap at this time, because we've learned quite a lot about comparing values. So we've learned that M is very strict and types matter. There's no implicit value conversion in the M language, and text comparisons by default are Unicode-based, ordinal and case-sensitive. Comparers are used by two types of functions to solve two different scenarios: ordering and sorting on one hand, and equality testing on the other hand. We've seen the three built-in comparers: compare ordinal, ignore case, and compare from culture. And amazing function, compare.equals, that lets you use one of the comparers for equality testing. It was probably a little bit more theoretical, but I think that's the foundation that you need to start building your own custom comparers. So are there any questions at this time that we need to discuss?
So at the moment, there is no question. I think your presentation is super clear, so there is no question at the moment. But I check that one. If I see something, I will raise that.
Perfect. Awesome. Thank you so much. So up to this point, we've talked about the built-in rulebooks only. But what happens when none of them quite match your requirement, right? Maybe there's some inconsistencies that you need to handle, or some quirky business rules, who knows, right, that you may need to apply. That's the domain of custom comparers. So from this point on, we are only interested in equality testing, nothing else. And we'll create a comparer that follows our rules. So we're not just going to ask, are these identical? We are going to change the question into, are these considered to be equal under these conditions? All right? So now the rules for creating a custom comparer for a task like that are pretty simple. I'd say there are only two rules that we need to take into account. First, a comparer needs to accept exactly two inputs. So one for each of the values being compared. And secondly, they need to return a logical value. So either a true or false. And that's it. That's all we need to take into account. We'll explore this by creating a custom comparer that replicates basic case-insensitive match, right? So the comparer is just a function. We're going to see how that works before we create something truly amazing. So here we go. I'll right-click one of my folders and I'll go New Query, Blank Query, and I'll open the advanced editor. I'll zoom in there and remove everything here. There we go. So like I said, a comparer is just a function that takes two inputs. Now, how do you initialize a function? With a set of parameters and with a set of parentheses. And between those parentheses, we can list our parameters for our function. So we can just pass in two names, X and Y, and this is followed by a goes to sign, and after which the function body follows. Now, the function body contains all of the logic that you want to be executed to obtain a result. It's pretty straightforward. Now, I think we all know the trick to making a comparison case insensitive. That's by forcing your inputs into the same letter casing before comparing them. So we will do that here as well. So we'll say text lower, for example, pass in the value for X, use a basic comparison operator. So we'll use the equal sign, and we'll do the same for our Y value, converting it into a lower text. So text lower, and pass our Y function there and hit done. Let me open that up. Awesome. So we just built our very first custom comparer. But I have to be honest, there's probably a better way to achieve the same results. And that leverages the built-in comparers under the hood. So we can write an equivalent to this function. Let's do so. I'm just going to duplicate this. And inside the formula bar, I'm going to get this expression and I'm going to rewrite it. Here we go. It's the function that we saw earlier, compare equals. So we'll use that. That lets us select one of the built-in comparers. So we'll do exactly the same and we'll call comparer or null ignore case. Pass that in. And now all we have to do is pass in our X and our Y value. Hit that tick and we're done. So this is equivalent to the function that we built before, but it delegates some of the rules to one of the built-in comparers. And comparer equals then converts the obtained number into a logical outcome, so either a true or a false. And this makes it so much more easier, I think, to picture adding additional rules on top, like exercising control over the input values, for example. So before we move on, there's one thing that I want to call out, and that's this. So let's get that out of the way. That only distracts. In most list functions, the comparer that's used for equality testing must be one of the built-in ones. But using a custom comparer will only raise an error in other cases. And there are exactly 5 exceptions. So these list functions accept a custom comparer, and they're all about answering 2 questions. Where is the value that we're looking for, or is the value there? So the list contains family and the list position of family. These functions accept a custom comparer. So now we know where custom comparers are allowed. We can use them in a couple of real-world scenarios. Let's take a look at our first one. Here we go. I think our first scenario is a very, very common one. It's when you're importing data from an unstructured data source, like a PDF, some sort of messy export. Who knows where the data is coming from? But it looks like this. It is messy. It has blank rows, junk rows on top, cells that look empty but contain white space, and a header row that appears somewhere in the middle and not always on the same line. So here on line 5, we see our header row of the table, the data that we are actually interested in. So in column 3, row 5, that's where our table starts. And of course, we are interested in getting rid of all of the junk on top and landing on this row, row number 5. Now, of course, when you open up the next file, it might be row number 3 or row number 7. So there's some logic that we want to create here. And in other cases, you might even find that it's not always landing in column 3. It might be column 2, column 5, or who knows. So we are going to create a custom comparer that follows our rules, and we'll design it in a way so we can apply it to 2 different scenarios. The first, finding that column header in a specific column, so in this case, in column 3. And secondly, finding that column header row somewhere on the row. So when we don't know in which of the columns that value is actually going to land. So here we go. I'll create a new query. So new query, blank query, because we are going to build our comparer first. Let's see, let's give that a name. So we'll call it function compare. There we go. And I'll open up the advanced editor and I'll zoom in. Get rid of this. Perfect. Now we're all ready to start building. So again, we're going to initialize our function with a set of parentheses, and between those parentheses, we can provide our parameters. In this case, I'll say input as any, and compare to as nullable text. We know that our function is supposed to yield a logical outcome, so as logical. Then the goes to sign, that's not right, that looks so much better. And then we have a function body, right? Now in that function body, I will call compare equals the star of the show. So compare equals, open that up. Let's hit enter, get rid of that. Okay. And the first thing that we're going to do is make a selection from one of those 3 built-in rulebooks. Of course, we are going to use compare or null ignore case, because who knows, maybe someone typed our thing that we're looking for in lowercase or in something else, something that we just don't know. We're going to ignore casing in that case. So here we go, ignore case, comma, enter. And here we're going to expand on that default rule set, because we are going to normalize the input. Now, like I said, we're going to build this function for 2 specific purposes: scanning all rows and looking at a specific column. That means that we can encounter different types of data. So the first course of action that I'm going to take is I'm going to get the value from input and convert it into text just to be safe. And of course, we're going to let that deal with nulls using the coalesce operator as well. So here we go. So text from, we're going to call our input. So that's the first parameter that we have there. So input, call that, use the coalesce operator, that's the double question sign, and provide a blank text string just in case we encounter a null. That means that our function won't break, right? So that's just a precaution. Then we are going to strip out any control characters and trim any leading or trailing spaces just in case they are there, who knows. So text clean, wrap that around it, and we'll do the same by text trim, trimming any spaces that are there. So text trim, wrap that around it as well. Awesome. Enter a comma, and then we're going to provide that second value to compare it to, which was called compare to. Awesome. Let's press done. And let's see if this works. Effectively, what I think we've built is something that looks like this. We have 2 values that are only equal if, after converting to text, dealing with nulls, cleaning, trimming, and ignoring case match, right? So that's the function that we've built just now. And we've extended the default rules for ignoring case by normalizing the value input. Okay, let's use this function to match a value in a known column. So I'll go back to my query here. Let's get rid of that. And we're going to, again, briefly think about that. What will that process look like? We are going to skip top rows until we encounter a value that matches, for example, the value date here in column 3, all right? So that's the thing that we're going to do. So table skip has a function condition, and that will skip rows as long as the condition is true. As soon as it encounters a false, it stops skipping and we'll keep everything else that remains. Okay, now knowing that, we have to invert the outcome of our comparer, right? Because that returns true if it found something. And that's when we want it to return false and stop skipping. So here we go. I can remove rows just to invoke it to get the bulk of the syntax, right? So I'm just going to enter a random value there, hit OK. So that just skips one row, but more importantly, it generated this syntax that I can leverage and adapt. So here we go. Instead of that 1, which is a numeric, we can also create that function condition. So we use the each expression to process each of the rows in our table. And like I said, we're going to invert the outcome of our compare function using the keyword not. Now we're going to call our fx compare, there it is, and pass in the 2 values to compare. Now the first thing that it's going to have to work through is values in column 3. So instead of square brackets, I can refer to that field name, column 3. And the second thing that I wanted to compare it to is something that I'm going to provide, and I'm going to provide one of the header row, or one of the names of the column headers, in this case, date. So as a string, date. Okay, let's hit that tick and see what happens. Perfect. Awesome. So I think this is a pretty simple pattern. And table skip is a pretty simple pattern too, but combining them is really powerful in finding a header row. So I will duplicate this step so we can expand on this basic idea for our second scenario. Here we go. I'm just going to copy that, hit the fx in front of the formula bar, replace everything that's there, and hit that tick just to confirm. So that just created a duplicate step, right, that I can leverage. Now, for our second scenario, we're going to assume that we don't know in which of the columns that date, the thing that we're looking for, is going to land. So how will we go about solving that? Well, first we need to scan the entire row. And when I click on one of those numbers, we can actually see that a row is a record in a table. We have all of the field names here and all of the field values there. So we can use a function record2list to get all of the cell values from each row to process that with our compare function. And then we can use one of those 5 list functions that we saw earlier to see if a match was found on that row. And in this case, I'm going to go for list contains any, all right? So that's what I'm thinking. So let's build it and see if it works. So list contains any, let's call that. It's asking for a list. Now, the list that we're going to process is each row in the table. So record to list, here we go, record to list, pass in the underscore belonging to the each expression to bring in all of the values from each of the rows one by one, comma, values as a list. So this is the thing that we're looking for, and we have to provide that value as a list. Lists are initialized by a set of those curly brackets. So I'm going to enter those. And between the curly brackets, I'm just going to pass the value that we're looking for. In this case, that will be date. Then we can invoke our custom comparer. We don't have to pass any arguments there because it will always process two values. The one from this side, and of course the value that we're matching, that's the second value that we've provided here. So let's hit that tick, and nothing seems to have happened, and that's actually a good thing because that means that this worked. Now let's see if that actually works, because I have a source 2, and of course now date is in a different column. So I'm going to pass source 2 to my final step and see if we're still picking up on this table on the top header row. Let's go. So instead of source, we'll provide source 2 and hit that tick. There we go. Awesome. So the nice thing about this pattern is that we're basically short-circuiting twice. Table skip will stop processing data as soon as it hits a false. And similarly, list that contains any will stop processing the moment it encounters a true value. All right, so now that we have this custom comparer, we can also invoke it on our sample data and see if we can get a better result when comparing value 1 against value 2. So here we go. I'll invoke a custom function. That's that one. Not to bother with the name, we'll use our custom compare function, select the values from a column, value 1, and compare it to value 2, which is also in a column. There we go. Hit OK. Perfect. And now the top 3 rows of this table, for which we saw value 1 had some inconsistencies, right? They now all return true. Perfect. Awesome. So are there any questions at this time about the stuff that we just covered?
There is a question that's about what are the differences between trim and clean, and that's the only question I can see in the chat. So for those people watching us, feel free, if you have any question, just raise it in the chat and I will ask Melissa during the presentation. But that's the only question we have at the moment, Melissa.
Yeah. So clean, that returns, let's say, control characters. So if you have tabs, line feeds, any of those things, text clean will get rid of them. Text trim will, without providing any additional arguments, will only trim leading and trailing spaces, white space, from your string. So that's why I'm using both of them in this case. Hope that answers the question. So let's go on to our final scenario, right? And that looks like this. So imagine that you are working with text, and in this case, German text. And you want to show all of the words, so all of the values in column 1 that contain one of a specific substring. And in this case, it would be this set of things that we're looking for. So this isn't a scenario, is this equals to that? It's, does this word contain any of these things with a culture-aware, case-insensitive comparison? All right? Sounds probably way more complicated than it needs to be, but here we go. We'll start again by building our custom comparer. I'll right-click that folder and I'll say new query, blank query, open up the advanced editor, zoom in, and let's start building that. So we know a comparer takes 2 inputs, and in this case, I'm going to call them substring and word. So substring, and that will be as text, comma, and then the word as nullable text. Of course, we intend to obtain a logical outcome, so as logical. Then the goes to sign, and now we entered the function body. Now in this case, I can't use compare equals because I'm not looking for a full match. I'm looking for a partial match. So in this case, I will leverage the function text.contains. So text contains, bring that up, and it's asking me two things, basically, text and a substring. Now, our text is word, comma, and the substring, of course, is substring. Let's pass that, but it also has an optional third argument, or it has a parameter which we can provide an argument value. And in this case, we will use compare from culture. So compare from culture, pass that in, and open that up. And we can provide it a culture tag. Now, we were working with German text, so that's DE. That should be something like this, comma, because we also have the option here to ignore case. So we just have to set that to true. Here we go. Let's press done and give this function a name as well. So ethics compare parts. Perfect. So conceptually, this function is answering the question, does this word contain any of these things according to German case insensitive rules? It's basically what we have just built. All right, so let's see if that actually works. And I'll step back to our look for list because I just want to call out that I've buffered this. That just means that if our query, if the M engine is scanning that multiple times, right, it can do so from memory, so it only has to evaluate it once. For this tiny sample, of course, it doesn't really matter much, but for larger tables, this can help with performance. Let's see our source, because I also added an has match column here, so we can easily tell which of the rows that should remain at the end of invoking our new custom comparer, right? So as you can see, rows 2 and 3, they return false, so they need to be dropped. All right. Now the key idea here is to use table.select rows, which takes a function condition and keeps rows when it evaluates to true. We'll use one of those 5 list functions again that accept a custom comparer. And again, it was going to be list contains any. All right, so I'll write this by hand and I'll press the FX so we can write that straight into the formula bar. Here we go. So table select rows, open that up, comma, condition as function. Again, we're going to process each of the rows in our table. So that's why we have that each keyword there. And then we'll use that list function. So list contains any, bring that up, open it, and now it wants lists as a list. So list is the things that we are looking for. So look for, we'll pass that there. Values as any, that's going to be the value in the value column of this table, and we need to pass that as a list. So enclose it in a set of those curly brackets, and just refer to its name in a set of square brackets. So there we go, value, comma, and now we have to pass it our equation criteria, which is the function that we just built, fx compare parts. Don't forget to put a closing bracket there as well and hit that check mark, and there we go. So if any of those comparison returns true inside list that contains, like list contains returns true and the row is kept, else the row is filtered out, and we end up selecting only those rows that contain at least one of the substrings that we specified according to our own rule set. So I want to give a big shout out to Bill Scissors, who in a blink of an eye found 2 different approaches to solve this scenario. And I really enjoyed that a lot. So thank you, Bill. I'm not going to spill the beans on that. You're more than welcome to find a different approach to solve this problem. It is definitely a lot of fun. Okay, so time to wrap up, because we've seen that a custom compare is just a function that takes 2 inputs and it returns true or false. You can modify the rulebook and normalize inputs, for example, within your custom comparer, so you can pre-build them for specific scenarios and things that you might encounter. Store them, take them out whenever you need. There are 5 list functions that accept a custom comparer for equality testing. They are the list contains family and the list position of family. But you've also seen that a custom comparer can be used when a logical value is expected, like within table.skip or table.select rows. So from now on, instead of asking, how do I fix my data to suit Power Query's needs, I'm hoping you're going to ask, how do I teach Power Query to play by my rules? So thank you so much for taking the time to join my session. I hope you've enjoyed it. And let me know if there are any questions.
Thank you so much. It was a great presentation as always, Melissa. There is no question in the chat, and the presentation was super clear. I don't think so. Any question remained to be asked. But Omid, do you have any question? Do you want to ask anything or add something here? Or no?
Actually, like always, Melissa presented in a really clear way, so there is no question for me, and I'm sure that other people enjoy it, and there is no question to ask.
Yeah, many of people mentioned that. That's great.
Awesome.
Okay, we can wrap it up. Thank you so much, Melissa, again for spending your time and knowledge with us. It's always a pleasure to learning from you and having you in this user group. Thanks again.
You're welcome. Thanks so much for having me.
Thank you.
Thank you.